So I don't know enough to answer that question is what it is. And that's always the danger. And this is why we sort of teach this too. So we have 8 teams in this class of 4 students. We have 32 students, and they've been broken. So we've got kids looking at the Jordan River, the Nile, the high plains in the aquifer, the Colorado, Bangladesh is another place that they're looking at. So they're looking at water crises in those places. And it's an educational process in that I'm learning about water, and my colleague is learning more about system dynamics and modeling, is what it is. And the first semester is all set up on the students getting a background in the particular area and problem they're looking at, clearly defining a problem statement and developing a causal loop diagram. And the second semester, they're going to be modeling, and I don't allow them to think about solutions until the second semester, until they have a running model that's capable of replicating the problem behavior. So yeah, so to a degree, I don't know. And this is just sort of the agenda. This won't take too long. Feel free to jump in at any time with questions. So I'm flexible about this stuff. So, and yeah, Thirsty City. So we start out the semester with this Thirsty City activities, which is what I'm really going to be talking about. And this is what came out over the summer when we were figuring out what are we going to teach. And for the sequence of courses, what we do is we write a proposal and it goes out to the faculty, and the faculty ends up selecting the proposal for the next sequence. So we got selected. So this summer we had to figure out, okay, now what are we going to do? And Robert came up with, let's start this class with something called Thirsty Cities, is what it is. And this is the activity that I'm going to talk about. It's how we kick the semester off. And so we don't talk about the syllabus. First day, they meet us outside of our building, and they are going to participate in this game. And their goal is to build the biggest city possible. And we have a 55-gallon drum that's filled up with water and that we can refill at the rate of 55 gallons per hour. The class runs for 75 minutes. Each team is given 3 buckets. They're about a 2-gallon bucket, maybe. They're given 3 buckets, and they're giving a trough. And then they can buy, they're given 25 cents to start out with, and they're given plastic cups with holes in the bottom. And the concept is that they need to transport water to their cities, fill up their cups, and then we're going to walk around every 15 or 20 minutes and pay them a penny for each cup, is what's occurring. So, and the idea is that they can't transport water, that they have to transport it in the trough. So they would go to this 55-gallon drum, and there's spigots at different levels on this drum too. Some are high, some are low. We also have an elbow at the bottom that sort of reaches up that they can't see. So the bottom spigot, it'll look like there's water in this plastic drum, but there's not. So they will fill it, they'll fill a bucket up, and then they will pour it into a trough, which will run down to the next bucket. And then they will fill that bucket up and they'll turn around and do the same process until they get to the location about 20 yards away from where that 55-gallon drum is. And part of this concept is that if you're distributing water in a city and stuff, that there are pipes underground, that you're going to have some leakage and you're going to lose water in that process. So we're hoping they're going to go through that process is what's happening. And I've mentioned this previously. It's 25 cents that they're starting out with. Their goal is to have the largest sustainable city that they can. And yeah, they're buying these cups, and they can always buy more cups, is what it is. So every time I'm going around and giving them money, they can use that money to purchase more cups so that they're able to grow and expand their cities. We also go around, and if any of their cups has no water in it, they lose those cups. We confiscate them. So they must keep their housing supplied. It's sort of random. Between 15 and 20 minutes, we circulate through this. We've done it twice. The second time we did it at 10 minutes. And yeah, this is pretty much what we're doing. And it's sort of a competition to a degree in that we're looking for the team that has the most money in houses at the end of this. So there is this sense of competition, but these are kids in this integrated science and technology program. They take in courses in physics, chemistry, biology, and the environmental sciences, energy. That it's really sort of well-rounded. So they should have some knowledge at this point. We have a record sheet that the folks keep. so that they are recording data so that we can have the data at the end of the game. And let's see. And this is just an example. You can see that drum, 55 gallons that we have, and you can see how it has spigots at different levels. And on their first pass, they were using these small cups, which were supposed to be used to fill up the houses. They were worried about leakage, so they didn't want to pour the big buckets in. But they're filling them up from different levels. There's 8 teams. There's 4 spigots around this thing, so some teams are going to have to wait. They would let the water drop down into the buckets that were lower, standing around until they were filled up and they could start moving. Just another photo of them moving things. You can see teams in the background are transporting their water. So it was relatively spread out. It wasn't an equal distance for everyone to the location of their cities, which is something that would happen in reality. So another example, they started just pouring it. So you've got someone holding the trough. You have someone pouring into the trough. And on the right, you can see Danielle is there collecting the water at the bottom of that trough. So they would have to do this 3 or 4 times to end up at the location of their cities. And just more. So these guys got sort of smart and realized we can use all 4 of our team members and we can start collecting the spilled water. So they were doing activities like that as they were going along. People are getting wet. There seemed to be a lot of energy. We had a perfectly sunny day for the 2 times we did this. And you can see one of these teams, what they started doing was they got into trouble on the left here and they started filling in, they were leaving the water in the buckets and putting houses in the buckets, is what it was, so that their houses would always have water. Over on the right, I'm going around and I am paying people out for the number of houses. And some students would wait to the last minute with their water to fill up just before I got there to pay them or to take their cups away. And you can see how we're spread out around this edge here in the front of our building. And yeah, there's the record sheet here on the left that they were keeping. And yeah, this team was building up the city quite well. They had 3 buckets over on the right posing for pictures. But what you can see they're starting to do with the cups is they started stacking the cups after a while so that the cups would leak into the other cups so that they could have more housing. We anticipated this would be like stacked housing or reusable water or something like that. They were recycling to a degree. So that started to occur. And you can see how the water is down there. It's been leaking out because of the holes. We did measurements in advance and we knew that the cup would last for about 4 minutes with water in. When it fell below the bottom rim, that's when we considered it empty and would take it out. So, and here's my colleague, Robert Brent, who's going around. He's collecting the cups. You can see the stack of cups he's already collected from having the students run out of water. And this was just a close-up of folks stacking the cups so that the hole was pointed over one of the other cups, and then they'd move it around when it started to get low, and they'd just fill the top one up to have more housing units in order to make more money. And this was sort of a super city over on the right is what's occurring. You can see how they really started stacking their houses and keeping that number up. And one of the other things that happened is you notice we gave each of the teams 3 pails. And this team ended up with 4 pails. So there was water theft that started to occur, and this was something we were able to talk about in the debrief. The second time we ran it, we decided that you could steal someone else's water, but you couldn't steal their buckets, is what it was, because that would be something that we physically located in the city. It's not like you go dig up their pipes and walk away with that stuff. And when we ended up running this the second time, we told the students, you guys, you should be debriefing this, telling you what happened to a degree, but what rules would you make up when you are doing this if you wanted to replay the game? And one of the things is they wanted bigger cups. So we said, okay, we can introduce bigger cups. And the rule is going to be that they're going to cost you 2 cents and we'll pay you 2 cents. They're going to be like hotels. And this group got very creative. They had the cups stacked, but the holes from these larger cups were pointed, so they were going over the edge and falling into the lower cups. So they had actually increased their capacity to recycle. And yeah, just a video of them.
And then so we're next and then we can make here wait. Maybe we just do triangles. Oh yeah, that's what we're doing. So put it right there. And then our next hotel will join you.
I can imagine that an earthquake would be
Yeah,
quite
so they would
devastating.
get crazy too. There's always these external things. So this was the result. So they were collecting data on the sheets. So after the first round, they had collected results, and this is what the results looked like. And you can see that there's money, there's houses, and there's both. And there's we didn't statistically look at this, but there's quite a wide variety. The winning team had a combination of 151, and the losing team, the low was they had a combination of 35 between the money they had and the houses they had. And the houses ranged, there was a high of 82. They happened to not be the winner. They put all their money into houses. But this is what their data looked like. So we took and we graphed that data. So the in-class assignment. So they've played the game. At the end of the class, we're out of time. So the next class they're showing up and we're in class and we give them an in-class assignment and we ask them to start reflecting on this type of stuff. And they were working in teams or in groups and, sort of just the warming up questions. What did you enjoy about the activity? What was frustrating? A list of different factors or elements that made it difficult to supply your city with water. There was a lot of complaints about fairness that, my city was farther away than some of the other cities. So, of course, we were not going to win. And then we asked them questions about how many houses they decided to build in their city and their thinking processes. And there wasn't much. And in what groups activity are different from the real world problem. So we asked them to be thinking of what's going on in the real world and what was actually happening in the cities. The idea of leakage is something that occurs in the city. This is where the idea of theft of water actually occurs out west in places and occurred during the game. There was talk of sabotage and stuff also, but we got them to sort of just reflect on what was common and what was different in from the game that they played to what they think is going on in the real world with this. And we asked them, what do you wish you knew about the game before starting? And to be thinking about not just the rules, but the dynamics, the behavior, what were the quantifiable parameters that they should be thinking about? Should they have done an analysis before they actually started? And then again, it was thinking about ways that we could or that they could be successful because we were going back out and we were going to play this again. And in the meantime, I had built a simulation model, a feedback model of this problem. And we put a user interface on it using Stella and put it up online so that students would have access to that. They could look at the structure of the model and they would be able to play with the model between classes, which I think beginning of the semester, very few of them actually did, is what it was. But that was part of this debrief. We didn't They were going to have access outside of class to the model if they wanted to test policies before they actually went in. And yeah, we just asked for a list of things and told them they could change the rules and stuff, but that they couldn't change the physics of the system because in the real world you wouldn't be able to do that. And that's pretty much where the hotels came up. And these are just some of the questions that I've gone through previously. So they were writing it out by hand, and we've scanned these. And yeah, the top left, the second one down, different factors or elements that made it difficult. It's people and other teams at the water station. So they weren't ahead of them. They had to wait in line for it to get filled. They were further away than other teams. Transportation, stealing is what they had mentioned were problems. They had problems keeping up with demand. They knew that they had overbuilt and that they had to have their houses reduced also. So we collected all this data for all the teams, and then we went back and we replayed the game. But this is the data from the first time. And what you can see is there's a lot of oscillation in the data. And this is their coins. This is the data we actually collected for the 70 minutes that the game ran. And they started out with 25 coins, and we just went at different time intervals, but made the data continuous. So we have the data for the coins, just some more comments from the folks. Oh, this is coins. I've gone backwards. Here is what was going on with their water level. So in the data sheet, they were keeping track of how much water they thought they had in terms of gallons stored in the buckets they had and in their city. So, and you can see that this is oscillating all over the place, different frequencies and stuff. And then the number of houses they had were increasing. There was only one team that reached a plateau and stayed at that around 40 houses. Most of the others, some oscillation and then explosion towards the end. And then this is the data for the coins and the houses. Again, it was oscillating around a bit. And then, yeah, what should the rules be? And they couldn't break physical laws. I've mentioned this earlier. And they didn't come up with a lot of decision rules. They just thought that they could be more efficient when they were doing this. That's where they really came up with the idea of super stacking the houses, the hotels, having the water flow into the cups that were lower down on the ground, things like that. And the funniest thing, this is where the simulator is. I can send this stuff to Eric. It's sort of large. We'll have to figure out how to get it to you. But the simulator is on IC Exchange. I'll show you a version of this at the end. It's on my computer. And then we met outside to play the game again. So the funniest thing, we've gone through this experience. We've showed them the data. It's oscillating. We anticipate they're going to know something about sustainability and whatnot. But it's a question, what are they paying attention to as juniors in college? And what shocked us the most was when we began the next game is that they ran to get the water. Like that would end up mattering in the long run. They wanted to be first. They almost killed themselves in the sprint to get to that 55-gallon drum. And this was the revised data sheet. So it's similar to what we had before. Hotels are added on this time as all. And again, they would receive 2 cents for those, but it would cost them 2 cents. And yeah, students were attempting to be more efficient. They believed that they had a strategy. And yeah, again, they ran to get the water. That was the
Well,
biggest
do,
thing.
do you
Go
think
ahead.
that strategy, Rod, was maximize your supply, and first maximize supply, then you can focus on housing.
Yeah, it was. They had to, so they could buy the housing, and we wouldn't come around until they'd gotten water at least once before we started dinging them if they ran out of water. So it was that. But I don't even think it was that sophisticated that they were thinking about maximizing the supply.
Mhm.
I think it was just, it's the competition kicks in and it's about
Yeah.
being first is what it is, which is a funny thing in the final debrief when we show them what was really going on and what was sustainable. So we play this game again, and it's similar behavior that these things are oscillating, that they're going up and down, and we never prohibited them from talking as a class or that they could have negotiated as teams and they didn't. And some of the teams in the first game and some of the strategies in the second game were like, let's sell our water to other folks or let's sell our houses to other folks, is what it was. So that was some of the strategies that they were using that they developed in the first game that they were using in the second. So they would go around and negotiate how much they would sell a bucket of water for, thinking we're better off ending up with money and fewer houses. So those strategies were taking place. Again, we are oscillating. This is the houses. So, they were able to get them to peak for a while and then they all ended up collapsing. And again, our filling of the bucket was sort of discrete. That 55-gallon drum is on the hour we refilled it. We told them in advance that it's a 55-gallon drum and we will fill it up at the start of an hour into class, and then you'll just have 15 minutes. We're going to refill it up right to the top. So they knew this coming in, and they built, and you can still see the collapse as they were running out just before the end of the class. And the hotels, a lot of people ended up investing in hotels and thought they could make more money and win the game that way. And then this is the data for the houses and the hotel. And then this is the data for the water. And this is the water that they had on hand in their buckets and perhaps in their houses. I'm pretty sure they were just measuring the water in their buckets at this point. And this is coins, houses, and hotels. Again, it's increasing, but it is oscillating. And this is one of the things, this is from my colleague emailed me this, right? And he's not a system dynamicist. He's familiar with it and stuff from being here. But he emailed this to me, and here's the data for today's activity. Look at the last graph. Full classes, houses, and hotels. This is the total amount of houses and hotels across the whole class at each time period. The blue line, the sustainable level, is what I calculated before the class even began. I had originally calculated 87, but I doubled it for the cup stacking, which passed water through 2 cups before being wasted. The class data fits that calculated value perfectly. It overshoots, comes down to the sustainable level, then starts to overshoot again. Is that beautiful data or what? That's the kind of thing that gets me excited. I hope the students see that. And we did emphasize that to the students. But for me, this was a big win in that I got a colleague I'm teaching with for the first time, not that familiar with system dynamics and stuff. We're doing a game that has feedback. He gets it and stuff. It relates to his world. And this data is coming out that he's excited about. And I have a computer simulation model that is matching that data. So this is what he did. So that's the total class is the blue line. It's what he was talking about in the email. And the sustainable level is what he estimated it to be. And now when I ran the simulation model, this is what I get. I'd started out with fewer houses, but you can see I had 100 houses in the model when it started. And we peaked at what the data actually peaked at was about just short of 400 houses was the maximum number of houses. And what we did is when they purchased a house, I collected the data. I kept the pennies from the number of houses we that they built so I could keep track of that. And we know they had 38, 380, 398 houses in that system. And that sustainably, it was around 175 houses. And the simulation model, if they had played it, would overshoot and peak at about their number of houses, and then it would decline and level off. And the big takeaway, and this is the end of when the class is over and just the kids having some fun knocking all the water. They made sure I was in the way to get wet. We had a professional photographer there taking pictures. And one of the key takeaways from this, and one of the things I learned, not being a water expert or anything, is that sustainable level is really a function of how much we were filling the tank up per hour, is what it is. We knew the drainage rate, and that for this water problem, it was the inflow had to equal the outflow, was what was going to determine your sustainable level of houses. And because they were building it based on that 55-gallon drum, which had a lot of water in it, they ended up overbuilding. And it was a way in the debrief for us to talk about reservoirs and lakes are really smoothing out the inflow over a period of time is all it's doing. And if they really wanted to sustain this, and what's going on in the real world is that are we overbuilding? And that eventually, because we're building on the reservoirs and the resources and the lack of communication between teams, would this actually be happening in the real world where we overbuild and then end up with these phenomenal water shortages? And again, I'm not a water expert, but it seemed to resonate. And it's now what, and what I'm going to do now is I'm just going to jump to and show you the interface we had for the simulation model they were playing with. And yeah, this is the model that I built. My units are all correct. And this is the user interface that they had access to online. And they all have Stella, and they could have had access to the model. I was making them ask first. And so this is online. And this is the data I showed you, and they can go and they can see the full structure of the model. And they can go to the interface page. And I built in some policies that they end up with negative numbers and stuff, which they should have picked up on. But I built a control switch into the model so they could regulate just how much water was going in so they could regulate the number of houses. So they could determine on their own water removed. The feedback system in the structure is just saying if you have houses, this is what the demand for water is. If the water is available, you're actually going to take it. And then you're going to lose houses if you don't have enough water, is all. And that was pretty much it. And yeah, I'm wondering, what do we do next? So we're actually going to teach 2 sections of this course next year is the plan. It's been a big hit. We've got oversubscription by students and stuff. And so we'll teach 2 sections next year, and we're planning on improving things, but I think this Thirsty City stuff was the way to engage students when we started out. So I'm looking for comments, questions. What do we do with this? How do we share this? Is it a bad idea? It's anything really.
Thanks so much, Rod. That was great.
Well,
That was very cool. We're open to questions, so jump on in.
So, Rod, in the beginning, you mentioned like all these other cities and countries that you were focused on too. Sorry, I got lost in this.
yeah, no, sorry, and that's on me. So that was the first activity we did, and that's what I want to talk about
Mm,
today. Course, over the course of the year, they're going to be looking at water problems in these different areas in the world. And the first time figuring it out, we looked, where are the big water crises in the world? We gave them a list of 13 different locations. And then the students got to pick the location and their team members that they would be participating with for the rest of the year. And this semester, what they're doing is they've done annotated bibliography, behavior over time graphs. We're using I'm pronouncing it wrong, DIPSR analysis of what the problems are also in these different regions. They've developed a causal loop diagram of this. And right now, they are writing up papers identifying the problem they're going to look at next semester. And next semester, they will be building a system dynamics model of this problem as part of a team. And in that, it's sort of labor intensive in that I require them to meet with me. So there's 8 teams. They got to meet with me an hour and a half outside of class each week, and we're drawing on the board these models, and then I kick them out. You got to document the model, you got to get data for the model. You have to have a running model before you come back next time, so it's built up gradually. And you should be writing this paper that's going to be due at the end of the semester. The other thing is we have my colleague, because he's a water quality expert, we've got people from that world who are coming in and will grill the students at the end of the semesters and presentations.
Cool. And you got a comment from Luis saying amazing. I never imagined that people could learn system dynamics in this way. I think I'm sure you're not the only one to think that too, but it's very neat.
I just wondered how you talked about calculating some things. How did you determine the outflow of this water? Because
Oh, that was a bucket. They had the spigots that they could control. So the the students would just drain the water from that 55-gallon drum and put it in their buckets is what it was. So they had complete control over the outflow. And that's pretty much why they ended up overbuilding and then it declined. But we had done the calculate. So we got the cups and we had a device. We poked a hole in each of the cups and then we filled a number of cups up and just measured how long it was going to take for the cups for the flow to come out. And then my colleague did the calculations, so he had the actual water flow data that he knew
yes,
what the sustainable level was. So if you had 55 gallons and it was being replaced at the rate of 55 gallons an hour, he knew what the inflow and the outflow should be and did the calculations based on that.
if you're using it all, yeah. But I mean, there are different ways that it could be used if you made the holes smaller. More,
Yes.
in other words, conserve the water more and that sort of thing.
Yep. And so some of the students got blades of grass and stuck them in the hole is what was going on. And we didn't realize this until we collected the cups at the end because we'll do this next year. And we found a lot of them with sticks and holes in them. I think it was just for 1 or 2 teams.
And then you have to add on the sewage water disposal.
Yes, yes, yes. So it was,
It's a
yeah.
great, for something, I mean, those kind of things that are fairly simple,
Yep.
but we give you all that information. It's really nice. I really
Yeah.
like it.
Yeah. It was a great way to start the course. Alice, you have your hand raised?
Yeah, what a fantastic experiment. Just really impressed by what you've done here. How did that translate into their performance in the course?
I have no idea. I,
Okay.
it graded high morale is what it is.
Yeah.
And the course seems to be going well. And it's, we have a mix of students that come into this program also. And I think my impression that the course is going well. I don't know how much they learn or take away from this type of stuff. We've done the beer game, and this is in previous courses that they have all taken, right? Because they're required courses. We have done fish banks. We have talked about how you engage people and how you have to work on a team and stuff. We even had them in teams for this activity, and they forget immediately that they're part of a team. There was no negotiation with the other teams. And yet we've gone through this and talked about this with Fish Bank and Tragedy of the Commons and how you have to negotiate. And they seem to forget it from class to class.
Mm.
And I think as they're doing these behavior over time graphs and they're doing these causal loop diagrams, one of the things I found is the most successful is I write up extensive, so they have to do these things, and we work with them in class in doing this. So it's more like a mentoring than it is a real class where we do a lot of lecturing. And they've done an annotated bibliography. And I sort of rip the daylights out, a lot of details and feedback, and am sort of nasty when I write details back to them. And then I don't grade them for the longest time. And I think they look at that and think they've done very, very bad. And then they sort of start doubling their efforts. And I see them as improving their materials. What they're doing really improves throughout the semester. And then I probably go back and grade easily is what it is. But there's something about seeing a lot of red ink and yet not knowing what your grade is and feeling like, oh no, man, we got to pick it up, particularly for team members who are slacking and stuff like that. So, but I don't, yeah, it's not like we tested or quizzed them on anything that they did in the beginning of the semester.
I was just thinking more about the motivation and the morale building and the team
Oh,
building would carry through.
that was high. We haven't had any kids drop. We've got waiting lists for. So there are similar courses that are being taught by colleagues. I'm not in those, and one's on the university. The other is on mining and the environment. And I know those kids have all wanted to jump into this class. The kids have talked about this enough that they put it on Instagram. Those photos I was showing you and stuff, the kids have put on Instagram. It's gotten a buzz, and the school papers talk to us about this and stuff too. So, yeah, and that's coming from the kids. So they must have been intrigued by it at least.
No, fantastic.
Yeah.
I remember in my undergrad days, which was like 400 years ago, I took a class, and it wasn't system dynamics, it wasn't called system thinking. I had no exposure at that time, but was all about in the province of New Brunswick in Canada, the St. John River was being overdammed.
Yeah.
And I still remember the lessons that were the key takeaway was that every dam raised the temperature and killed fish.
Yeah.
And so that until the study by the environmentalists, that was just not part of anybody's thinking.
Yeah. And it seems it's such a great lesson, the idea of to be looking at the inflows and outflows. And we hammer that into them a lot with the modeling stuff we do here is, you know, if you have a problem, if the model's not working, look at the inflows and the outflows and start backing up. But, when are things in equilibrium? When are they growing? When are they declining? It's the inflows and the outflows you should be looking at also. So,
Yeah, great.
Your comment about teams makes me think of I study chronic wasting disease in deer in the US, and um, there's some move now to coordinate at a regional level, but that isn't really being done. So it made me think like every state is almost its own team, right? And they know that they're being influenced by other states because some states don't control it and then other states do control the disease. So it's like, but if you're in a state that does control and you're surrounded by states that don't control the disease, then you're just like fighting this uphill battle. So I think people all over maybe that's human nature, I don't know, but they don't remember that they could talk to each other or negotiate or something, that they're part of this bigger world. That's interesting.
I played fish banks a few weeks ago in the undergraduate class, and it was I usually offer $40 to the winning team and stuff, and it's very competitive. They look like MBA students the way they crash it and stuff. And it was during the debrief. And I tell them this is a sustainability game and stuff too, right? And during the debrief, one of the students said, "Oh, this is about sustainability." And it was just a great opportunity. It was sort of an epiphany for me. The idea, everything we do is sustainability, right? No matter what business you're in, no matter what you're doing, if it's not sustainable, if the environment is not sustainable, we're sort of all out of luck. And that was a great opportunity to sort of just hammer in the kids. You got to be kidding. It's all about sustainability, right? And even with fish banks, we'll make them run it a second time to see if they will negotiate with each other so that they could have a longer term. And they tend to, yeah, they tend to mess that up also. So, but I'm hopeful.
Araya also asked a question. Can you see that in the chat?
Yes.
Or regarding the outlet flow rate, could it be modeled as dependent on the water pressure, i.e., the height of the water above the hole? If so, would a gradual or optimized pattern of adding water change the system's behavior in a meaningful way?
Yes, so that was the problem because even with the cups, that's why we had if the water fell below the bottom rim, because as the water fell, the pressure would be less, so our flow would end up being reduced. I imagine that we could do that, and I would argue that if we were to do a more detailed model of this, this is the water consumption at the household level has to be the decision making of people is what it is, right? That they're deciding how many showers and how many laundries and how many times to wash your car and stuff. So my colleague does that type of modeling is what it is. So, and that's what he did to figure the flow rates out of the cups and stuff to figure out how we were going to set this up. So that could be done, but we have not done that. And this is something where the great thing about teaching with colleagues like this is I'm always learning stuff, is what it is, right? I'm learning the terminology, I'm learning the equations that they're using. It's extremely beneficial, but we had not done that. But I imagine that you could do that and that we could have a model of that so that the flow pressures would change. That one of the big things we did was it was just so smart to have an elbow for the bottom spigot inside of that 55-gallon drum. So it was plastic so they could see the water, but they could not see the spigot on the inside or that elbow that was pointing up. So they saw the water level fall and then no water was coming out. And as the water in the drum is declining, the pressure is declining so that they're getting less and less water. It's taking them longer to fill up. They were able to realize that also. But that elbow was a great example because then we could go in and show them pictures of Lake Mead and what's actually been happening with Lake Mead and just sort of hit home that this is going on in the real world. And I believe Lake Mead has now, they reduced at one point their intake valves, right? Because the water level had dropped so much. But that this is happening in the real world, and you don't put those intake valves at the bottom because of sediment buildup and things like that. So,
Really cool. CT?
I was wondering if you're interested in ever changing the goal of not having houses, not money, and having everybody consider themselves on the same team.
yeah, I think if I did it a second time or third time, we could do that. And we were hoping that they would come to those conclusions on their own. And we ended up discussing that in the debrief, is that they were all drawing from the same water source. So no matter what about these, political boundaries, you're all in the same watershed, and there should be some type of communication that is occurring there. And in the beginning of this course, my colleague is talking about, like water rights out west and, yeah, how do water rights work and stuff. So after they did this experience, we were sort of discussing those types of issues also. So, but yeah. So I guess I have that question, and that'd be a good question for this group is, I mean, we don't want, to a degree, it's the failure. It's their decision making that leads to the failure, is where in a debrief we can point out the mistakes they made and the fact that it came from their decision making. If they went in and played the game and were just successful first time, if that happens, I'm sort of going to be stuck at how am I going to debrief this?
Good thing you're working with enough different people that even if one or two people gets it, then
Yeah, yeah,
it'll never work
yeah,
perfectly.
yeah. There won't be that cooperation.
I also
Ah,
have another idea.
yeah.
They could see each other, right? What if
Oh,
they're
yes.
so far from each other they don't actually know, like, if they're doing better or
Oh,
worse than the other team?
No, they were close. It's there's a lot of activity going on and they're very busy filling their cups up, moving back and forth. So typically what happened, they'd have three people go to collect water after the first round, and one people would be there with a bucket measuring so that they didn't run out of water or any of the houses didn't run out of water. But yeah, they could see around, and folks next to each other were stealing ideas from each other is what's occurring. Once one person figured out to start stacking the cups, then the teams next to them started stacking the cups. So there was a diffusion of that information going on, but I don't think it reached the teams from one end or the other is what it is. And there were just 8 teams there, but
That's probably how life is, right? You
yeah,
kind of like the people that are next to you, you see more and then kind of
yeah,
spreads.
yeah. Start learning from them first.
Yeah, interesting. Well, thanks so much, Rod. This is great. Anyone other remaining questions? In management, we call this benchmarking. Yeah, exactly. Yeah.
I've thrown my contact information, my email address into the link if anyone wants anything or to reach out later. And my recommendation is you may have to bug me. Sometimes get busy during the semester and stuff, and I'm giving you permission to bug me if I don't respond in 24 hours.
Okay, if
Let-
you could also share the link of the exchange model.
Sure.
Oh yeah. Hmm.
Yep. Yeah, that's a good idea. I should have thought about throwing it in there. And it is.
And Len, you've got your hand up. You can jump in too. Oh, we can't hear you for some reason.
How about now?
Now, yep.
Okay. So, Rod, do you ever introduce the classic tragedy of the commons literature in the course?
So they get that in other environmental courses here
Okay.
that's occurred. So they should have that.
Then I got a project for you. You and I need to work on something called scale feedback. What if you
Okay.
could let tens of thousands of people know what's going on
Yes.
simultaneously?
Yeah.
Okay. Thanks.
And I dumped it into the IC Exchange link, but it's coming up blurred. I'm gonna try to do a better job of that.
No, but it's working.
Okay, good.
Yeah,
Yeah,
it's working. Thank you. Thank you, Rod.
very welcome.